Hi! In this video we will go through how to set up your report and the overall structure. Also we will look at how to set up your chapters to ensure a good flow through the report. And I will also give you some tips and tricks to get an even better structure. The method of presentation will be, I will give some reasoning and some theory, and then I will show you an example with a blank paper approach. So why should you set up your report in a certain way? Why does it matter? Well, you might know everything, but me as a reader, I do not. So it can be quite confusing and even frustrating if you didn't set up your report in a structured way with a good flow. And you don't want your supervisor to feel like that when he reads your report. If your supervisor also just breezes through, they are actually less likely to catch mistakes. Finally, and for me this is the most important part, your report, you're spending a lot of time on it. It needs to be operational. With that I mean the group that comes after you needs to be able to take your report, read it, and then they know what you did, why you did it, how you did it, what the results were, what you would improve. They can basically start standing on your shoulders and thus see further. So sometimes I also say, write the report that you yourself would like to be the reader of when you take over a project from another group. So one way of structuring your report is using the double diamond method. And by double diamond, I know many of you will think of it as a project management tool, but you can also use it as a project report structuring tool. By this, I in no way mean that you should make a chronologic report. The chronology of a project can many times go in loops and can be quite complex. And if you write your report in that way, you will lose the reader and he will not get your important points. Write a structured, easy to follow report. That's what will give you the best grade. When I say using the double diamond method, what I mean is start by making your user understand where you come from, and then your discovery phase. Take him with you on your discovery phase. Explain the problem, okay? And then explain how you defined your problem given this discovery phase. Then, once you define your problem, explain the process of developing your product. And then describe your solution, what you delivered, how well does it perform, describe your tests. It is kind of chronologic, but it's kind of a fake ideal chronology. A method I also like to use is mirroring. So you kind of in the middle, you kind of can flip. We always start with a table of contents, and a table of contents could look like this. I think it's a good way of structuring it, where you have the preface, and actually the preface is where you thank people and stuff like that, and it kind of also goes together with the references, where you are thanking the references that you used. Then next comes the introduction, the problem analysis, and the market research. And this you are answering with your perspectives, with your economic, your environment, and your societal impacts. So you are relating it together. Your perspectivation is pointing back at the introduction and saying, okay, what do we move with our product? Then we have the problem formulation and the problem limitation, and that is what you are answering in your conclusion. Okay, so your conclusion should answer the questions that you were posing in your problem formulation. And it should relate the limitations you made, how to handle those, how did you handle those, how should anyone taking this to the next level, how should they move on from there. Then we have the specification of requirements, and this we are using in the prototyping, documentation, calculation, test and discussion phase. The tests are showing if you're fulfilling your specification of requirements. Your documentation is showing, your calculations are showing that you're fulfilling these. Then you have your methods chapter. Many students are skipping that within engineering, not so much in other science disciplines. The methods are quite important to describe, as I told in a previous video. The methods are used during your idea analysis and your idea evaluation. So basically the morphology diagram steps 3 to 7, they are defined by your methods. Then there's the theory, and there's the morphology diagram step 1. Here it's the idea creation and morphology diagram step 2 that is pointing towards that theory. The mirroring kind of tells you what needs to be in which part and in which order to be able to answer all the questions posed in the first part by the second part. I hope that makes sense. That was about structuring the report. What goes where? Another tool to get a good flow in your report and a good structure is to relate every chapter in your report to the overarching problem, just with 2 to 4 lines. In every chapter, I like to have a short chapter introduction and at the end a short chapter conclusion or part conclusion. In the introduction, we tell them, what do you do in this chapter and why do you do it? Why is this important for your overall problem? And then you look at what is the purpose of that chapter towards solving the overarching problem. Okay, so you're looking at what's the problem and you're pointing towards a solution, and you're saying, okay, this is the piece of the puzzle that brings us one step closer to solving this problem. Okay, that's the introduction. Just 2 to 4 lines. I'll give an example in just a moment. Then the chapter conclusion, it's a very short resume. What did you find during that chapter? Also, this is where you point to what do you do next. So you're already kind of introducing the next part. And also you should write very short, what are the consequences of what you found in this chapter? What are the consequences to the overarching problem? Okay, let's try to imagine that we have made a DC motor torque calculation because we have some requirements. And we would like to put this calculation into a context. Remember, calculations belong in appendix, not in the report, but still in appendix it needs to flow well, so you need to put that calculation into context. Okay, we will do that with a short chapter introduction and then a short chapter conclusion. We are calculating the DC motor torque. We imagine in this square box there's a calculation and a figure and all that good stuff. Let's start by telling what we will do in this chapter. To select the correct DC motor, a dimensioning calculation is made for the robot chassis propulsion. Now that puts it into context. The correct motor will enable the robot to climb the relevant inclines and achieve the relevant speed as detailed in the specification of requirements, and then some reference to that. It could look something like this. So we tell why we do it. We do it to select the correct DC motor. We tell what it is we do. It's for the DC motor of the robot chassis propulsion, and it's a dimensioning calculation, and we put it into perspective with respect to the overarching problem. Good. Then we do the calculation and we find out. Okay. The calculation shows that we need a series wound DC motor to achieve high speeds at low inclines and high torque but low speed at high inclines. The required stall torque is a certain number and the required no-load speed is a certain number. You could have other numbers that came out of this calculation which you would like to mention here. This now enables us to select the correct motor as well as calculate the required battery voltage and capacity and current output. So now we wrote a short resume of the result we found. We found that we need a series wound DC motor and why, and these are the stall torque and no-load speeds we need to look for. There might be other details, of course. This is just to keep the example short. And then what do we do next? Well, we need to select the correct motor with respect to manufacturer and so on. And now we need to calculate the required battery voltage, capacity and current output. Okay, finally some tips and tricks for you. The first tip is, if you have the time to finish your report in good time, then you can take a few days away from the report and then come back to it. And that enables you somewhat to read it with fresh eyes, to check if the order is correct. You cannot do that because you made the project. You already know all the answers. Your reader does not know. Have somebody else check the entire report. Somebody who was not part of your project. Okay? It's called red reading. If they understand it, then it's good. But usually they will ask some questions. If they ask questions, it's not them that's stupid. It's you that didn't present it in the right order. So try to see, okay, can we move that information earlier? Or can we reference or something to solve this issue, this question, so it doesn't occur? As for the next thing, to check if you forgot to document something, this is really difficult. Even your red readers might not catch it. What I like to do is I like to look at the prototype, look at every little detail and see, can I point at anything which is not documented in the report or in the appendix and explained and calculated and all that good stuff. If you cannot point anywhere on your prototype and find something that was not documented, and you followed my guideline for your table of contents, then the risk of having missed something is quite small. So, good luck to you and thank you.